Okay, here we have relative velocity. A car travels at 60 kilometers per hour on a bearing of 315 degrees true. The driver observes another car traveling at 75 kilometers per hour towards west. Find the actual velocity of the other car. So we've got car A, which is traveling at 60 kilometers per hour on a bearing of 315 degrees from true. So all the way up there. And that's 60 kilometers per hour. So that's 45 degrees in there. So that's car A. While I've got this picture, I'm going to draw my vector. So the velocity of car A is equal to negative 60 because here it's in the negative x or negative I direction. So negative 60 cos 45 degrees I. Plus 60 sine 45 degrees J. Okay, so that's velocity of A. Next, I have car B. Now, I don't know the actual velocity of the other car, so this is what I'm trying to find out. What I do know is that I have the driver observes another car traveling at 75 kilometers per hour. So I have the velocity of the B car relative to car A. And I know that that's 75 kilometers per hour towards west. So towards west is this way. And that's 75 kilometers per hour. So the velocity of B relative to A is equal to negative 75 I. Now our formula for velocity is the velocity of B relative to A plus the velocity of A equals the velocity of B. So there's no need to rearrange here. So the velocity of B relative to A is negative 75I, and the velocity of A is this one here. So all I'm going to do is add my I and J components. So negative 75 plus negative 60 cos 45 will get you negative 117.43I. And then J is just this here. So 60 sine 45, which is plus 42.43J. And that's equal to the velocity of B. But we still have to find the actual velocity. So not as a vector, we want to find the magnitude of it. So the magnitude of the velocity of B, so the square root of this squared plus this squared, and you will get 124.9 kilometers per hour. As our other magnitudes here were in kilometers per hour. Okay, now we're just going to find a direction. So if you graph this here, if you graph this here, we have, so negative plus, so it's somewhere up there, so I'm going to find theta. So theta equals the inverse tan of, it'll be 42.43. I'm running out of room, divided by 117.43. And that gets you roughly 20 degrees. So what we say, I'm just going to come up in the center here. So VB equals 124.9 kilometers per hour, and I'm really running out of room, at 289.9 degrees true. So you want it from true here. So all the way around. So from here all the way around. So it's that 20 degrees plus our 270. So roughly 290 degrees.